Good morning. My name is Mike Goodson, and this is my presentation on network termination panels. So first off, who has ever seen or knows of a termination panel? Anybody else other than cable? I know all of us do. Well, you already went through cable. So this is essentially the board that you all get to do with cabling, and this is a couple of the blocks that I'll be talking about. So 110 and a 66 and a 110 block. Those are the major ones for termination that you'll find doing networking. But a network termination panel or patch panel is a mounted hardware unit containing an assembly of port locations and a communications or other electronic or electrical system. In a network, a patch panel serves as a sort of static switchboard using cables to interconnect computers within the area of a local area network or LAN, and to the outside for connection to the internet or other wide area network, or WAN. The patch panel uses a sort of jumper cable called a patch cord to create each interconnection. Patch panels serve as a nerve center for the cabling network. Simply put, the patch panel is where all the horizontal cabling in the infrastructure is consolidated. Patch panels let you terminate cable elements and connect the signal via patch cord to its final destination. Patch panels form the main link to collect data and route it where it needs to go. Patch panels are critical, and if a malfunction occurs, it can cause the whole system to fail. And of course, there's a picture of a 66 block, which is mainly used for telecommunications or voice termination panel, and the 110 block is mainly used for a data termination panel. And he's going to pass around the I-66 block and a port termination panel. The 66 block is a type of punch-down block used to connect sets of wires in a telephone system. They've been manufactured in three sizes, A, B, and M. A and B have 6 clips in each row, while M only has 4. The A block spaced the rows further apart and has been obsolete for many years. The B style is used mainly in distribution panels, where several destinations need to connect to the same source. 66 blocks are designed to terminate 22 through 26 American wire gauge solid copper wire. The 66 series connected block, introduced in the Bell system in 1962, was the first terminating device with insulation displacement connector technology. The term 66 block reflects its Western Electric model number. Well, here's a couple of blocks. So of course, the A block is on top. I couldn't find a picture of a B block anywhere, and then the M block is primarily what we use today. It's more popular. And also, a 110 block is a type of punch block used to terminate runs of on-premises wiring in a structured cabling system. The designation 110 is also used to describe a type of insulation displacement contact connector used to terminate twisted pair cables, which uses a punch-down tool similar to the older 66 block. The 110 style insulation displacement contact connection is often used at both ends of category cable runs through buildings. In telecommunications rooms, 110 blocks are often built into the back of patch panels to terminate cable runs. At the other end, 110 connections may be used with keystone modules that are attached to wall plates. The 110 blocks are preferred over 66 blocks in high-speed networks because they introduce less crosstalk, and many are certified for use in Category 5, Category 6, and Category 6A wiring systems. An insulation displacement contact, IDC, also known as an insulating piercing contact, is an electrical connector designed to be connected to the conductor of an insulated cable by a connection process, which forces selectively sharpened blade or blades through the insulation, bypassing the need to strip the conductors of insulation before connecting. When properly made, the connector blade cold welds to the conductor, making a theoretically reliable gas-tight connection. And here is a picture of the wires going through a 110 that have not been terminated yet. A punch-down tool is a small hand tool used by telecommunication and network technicians. It is used for inserting wire into insulation displacement connectors on punch-down blocks, patch panels, and keystone modules. And there's a picture of a punch-down tool with both blades. There's a 66 blade, which is more of a flat rectangular blade, and then a 110 blade. And most punch-down tools are of the impact type, consisting of a handle, an internal spring mechanism, and a removable slotted blade. To use the punch-down tool, a wire is pre-positioned into a slot post on a punch block, and then the punch-down tool is pressed down on top of the wire. It's pressed on top of the wire over the post. Once the required pressure is reached, an internal spring is triggered and the blade pushes the wire into the slot, simultaneously cutting the insulation and securing the wire. The tool blade does not cut through the wire insulation to make contact, but rather the sharp edges of the slot and the contact post itself slice through the insulation. As the picture shows, this is one that's terminating wire on a 110 block, and only one side of the blade, or one side of the blade has a cutting knife on it, which is on the bottom, which cuts the outside of cuts the outside of the wire. I'm going to have a quick video that demonstrates this.
Okay, this is a quick demonstration on how to terminate on a 110 block. This is a 110 block. These are Cat 5 cables coming in. I'm just going to terminate 6 cables today, so that means I'm going to route 3 in on your left side, 3 in on your right side. Alright, as you can see, I stripped the cable back so I can use the pull string to pull that cable to the right length that I want to terminate at. I'm going to do that. Take the snips here, cut this pull string and cut that existing jacket off. So, and you're going to go with 568D today. That will be blue. Start with your white, blue, and blue. White blue is the tip, blue is the ring. Go with orange, white orange, orange. So, green, white green, and green. Brown, white, brown, brown. All right. This is your standard punch down. This is a 110 punch down blade on here. Okay, gonna cut this with the cutting side up because the cables are facing up like so. Good blade, the cable will just fall off like that. That will be your termination. Then you grab your C4 clip. This is a C4 clip, which is color coded. The same way I just punched it down here. So I put it on first. Normally I just put mine right there on the white green and give it a good hit. It should see this up. See at the top, there's little notches that catches it that makes sure it's secret. And I will continue to do that all the way through.
So he makes it look pretty easy, and it really is just to do that. It's not a very difficult process. It's sometimes hard to make sure the wires get in the right place. It's easy to cross them up, so you got to be careful of that. And another a modular jack is a keystone jack, which is this is a category 6, and it is used for the wall jacks to put in. So it makes it customizable when you're putting it in, so you can run different runs to wall outlets. So you can, if you need 2, 3, 4, 6, you can color code them. That's a picture of the back. They just kind of snap into place after you put the keystone and terminate your wires into the keystone. Then you just snap them into the wall plate and screw the wall plate in and test it. Hopefully it works. But it is no accident that ports are packaged in an 8-port module. It is much easier to replace or fix the panel on a smaller scale. Fewer number of ports that must be replaced in the event of a malfunction means that the fewer wires that must be terminated to the new module. This can make all the difference when a critical customer's network fails, such as that of a bank or a brokerage house. Often found in a building's telecommunication closet, patch panels serve as a central role in the administration of the telecommunications network. They provide ease of administration by enabling the process of moves, additions, and changes in complex spaces. In today's complex office architecture, patch panels represent the only way to transfer lines from one office to the next. For example, if two workers must transfer desk locations, the simple switch of patch cords into various ports on a patch panel can ease the move. Without this capability, much time and energy would be spent terminating cable that would have to be hardwired. And as you can see in the picture, it gets pretty complicated when you get a lot of termination wires, a lot of jacks that have to be wired. And if proper planning, organizing, and maintenance are not common practices exercised routinely, then your telecommunications closet can get out of control and unmanageable in a short amount of time. And who wants to go try to troubleshoot a mess like this and it looks like a wall of, spaghetti or something? And if you can turn that into this, then you will be a company's hero, without a doubt. I'll have a quick video too to demonstrate that. More than likely, if you're lucky, you'll be brought in to try to fix some of these at one time or another. The company I used to work for, it was 10 times worse than this. When they had stuff running from the walls down, you couldn't even walk through the room. It was so dense with cables coming out of the walls. It was crazy. So as you can see, there's some pretty horrific examples of what it can get to in a hurry. Patch panels are one of the few components used in both copper and fiber cabling networks. Some professionals are adamant that there is no real difference in the performance and construction, while others see a drastic differential between the copper and fiber products. The professionals concur, however, that the cost of fiber panels, while having improved over the past few years, is far more than the copper equivalent. This explains that the cost of actual installation is compatible, but estimates of a 30% to 40% per port premium for fiber panels over copper panels. And these are some examples of a fiber optic termination panels, which I don't know why they don't see a difference, because fiber is a lot faster than copper. Copper panels are typically constructed with an 8-pin modular ports on one side and 110 insulation displacement connector blocks on the other side. Wires come into the panel and are punched down or terminated into the IDC block. And on the opposite side of the panel is a patch cord, most often featuring an 8-pin modular connector that plugs into the port corresponding to the wires terminated on the reverse side. And the patch cord lets the signal be patched from one location to another. This is a picture of a typical, probably home network, a small one for just a single household. Ports are one of the most important patch panel components. These physical connection points provide a place for data to enter and exit the panel. The majority of copper panels have one wire terminated to an IDC block at the back of the panel, and then an 8-pin modular port on the front of the panel. Patch cords can then easily be placed into ports, which we pass around one of these. It's the front and back. I guess you'll have to look at that. Patch panels typically consist of 4 or 8 modules of 8 ports each for a total of 24 or 48 ports respectively. Panels can consist up to 96 ports and have been known to reach 336. A company named Telect even offers a patch panel featuring 1,536 ports for backbone fiber optic cable. There is no physical limit to the number of ports possible on a panel. As long as there is room, you can fill up an 8-foot track without interfering with the integrity of the panel. And here I found a picture. This one actually has 144 fiber optic ports on it, which is somewhere down there. And now I've got a demonstration of a guy who really did a good job in a wiring closet.
We have our vertical cabling in the back of the patch panels. As you can see, all the cables are nice and neat, punched down, no excess weight pulling on the cables, causing them to become loose or just eventually wear out from the weight pulling down on them from the patch panel. As you can see, we move up to the next step. We have the same thing. And on and on. This particular wiring closet has 9 switches. As we move around to the front, you can see that everything is nice and neat. 9 switches going to 9 patch panels. Actually 9 48 port switches going to 9 48 port patch panels. As you get into closer here, you can see that the top cable goes to the top switch port. The bottom cable goes to the bottom switch port. Makes it very easy when you're toning out the cable. Wire management, which I've always thought was an oxymoron, has been eliminated. 1-foot cables are used, creating a nice, clean horseshoe design. And the cable management rack on the side with all the cables, the vertical cabling runs down through. It can be very pleasing to the eye. I have 31 other wiring closets in the hospital, all with the same design. Most of them have less switches. These are 3750 stack wise switches, of course, with 9, so that's the maximum number they can use. That's why we have the next cabinet over here for future growth.
And that was a pretty good example of how you're supposed to do it. Limit it by floors and make it simple if you can. All right, does anybody have any questions about any termination panels? All right, well, thank you. That'll conclude my presentation for network termination panels.